Hello and welcome to a croaky ramble. With me, today we are talking about IEB's paper 2 from May 2025. Question 5b, let's go. In triangle DBC, we have that B is 90, which they have not filled in for us on the diagram, so we are going to go ahead and fill that in ourselves. And we're also told that EF is perpendicular to DC, and that they have filled in for us on the diagram. Reasons must be given in this question. You're asked to prove that CB over CD is equal to CF over CE. So that for me immediately, if I just think about the sides in question, we've got CB. Maybe I use a highlighter. So they're talking about CB, and they're talking about CD, which are part of the big triangle, and then they're talking about CF and CE, which is part of the smaller triangle. So that kind of hints to me that we're looking at a question of similarity. If we can prove that these triangles are similar, then I think we will be able to prove this conundrum. Another thing I'm thinking about is SOHCAHTOA, because the big triangle and the small triangle share this angle in common. So let's see, in this triangle, the small one, we're being asked to show a ratio between CF and FE, which we would be using tan, whereas in the bigger triangle, it would be adjacent and hypotenuse would be using cos. So yeah, maybe not quite, but actually very interesting, because basically this is effectively telling us CB over CD is cos of C, and CF over CE is tan of C. No, it's not. CF adjacent over opposite would be cotangent, which you might have learnt about in grade 10 and then promptly forgotten about because no one ever mentioned it again. So effectively we're being told that cos of C adjacent over hypotenuse is equal to cot of C. CF, oh, it's CF over CE. CF over CE, so that would be adjacent over hypotenuse as well. Oh, I highlighted the wrong side. Oh my gosh. Not FE, but CE. So that's actually quite easy then. So you could literally just say CB over CD is equal to cos C, and similarly CF over CE is also equal to cos of C, because both of these triangles are right angled. They've told us that, so we can use SOHCAHTOA. And so therefore CB over CD is equal to CF over CE. So hey, that's one way you could prove it, and there aren't really reasons you can give. I mean, yeah, the reasons are baked into the explanation. But anyway, let's do it the similarity way. So we would just have to say in triangle CBD, which is the big one, and triangle CFE, which is the small one, we just want to show that they are equiangular. So firstly, we know that C is common to both of them, right? And then the next thing we know is that angle B is equal to angle EFC, which we were given, right? We're told that both of them are 90. And then finally, angle D will be equal to this angle, which is angle FEC. And that will be because, look, I don't know if third angle is still a valid reason, but anyway, effectively it's interior angles of a triangle, or angle sum of a triangle, or whatever, right? The fact that they have two angles equal means the third angle must also be the same, because both the angle sets need to add up to 180. So then from there we can make our statement that triangle CBD is similar to triangle CFE. Whoa, where is my triangle? Right, and that is because of AAA, angle, angle, angle. Right, and then from there what we are interested in is CB, CF, and CD and CE, right? So this similarity that we've proven shows us that CB over CF is equal to, this is not going to go where I wanted to go, but anyway, is equal to CD over CE, right? That's because of what we just proven, the fact that CBD is similar to CFE. Okay, but this isn't quite what we are asked to prove. Our things are a bit diametrical. We've got CB over CF, CD over CE. They're not in the right place, so we just need to rearrange, do a bit of manipulation to rearrange. So I want CF up here, so I'm gonna, I want CF up here, so I'm going to times both sides by CF. Okay, so we've got CB is equal to CD times CF over CE. CE is good where it is. We've got CF at the top. CD needs to go. Okay, we need it down here. So I'm going to times by 1 over CD and do the same on this side. So then CB over CD is then equal to CF over CE, which is what we were required to prove. And that's that on that, kids. So let's see what the memo thinks. Right, so we prove that they are similar, and then we okay, yeah, then we just manipulate away. BC over DC. Okay, I guess we could just leap right ahead. But yeah, all good. I don't really know what to say. I don't know what's going on in this diagram, in this memo. Anyway, but yeah, whatever. The gist of it is the same. So cool. Let's leave it at that, and then convene again to discuss a future question.